Well, welcome everybody to the next in our series of Experience CGI, and our podcast today is going to be looking and visiting the exciting world of emerging technologies. I'm Steve Evans, and I'm delighted to say I'm joined today by Neville Richards. And for those of you that have joined us in previous podcasts, you'll know that Neville looks after our advanced operational technology area, and today we're talking to Neville live from Australia about quantum and quantum compute. So hello Neville, good morning from the Northern Hemisphere.
Good morning.
Great to have you on the podcast. You and I have been knocking around this idea of quantum and what it means and what it can do. And are we ready for quantum, which is really what we're going to start to get into on our podcast today. So maybe just to kind of start us off, to bring it to life a little bit, I wonder if you could just give us a little flavour of this conversation we were having the other week about the cat.
Certainly.
To explain what quantum is.
Quantum mechanics deals with many ideas, including the ideas of superposition, interference, and an entanglement. Schrödinger created a theoretical cat, which has become famous in quantum physics, called Schrödinger's cat. The hypothetical cat demonstrates the idea of superposition. That is, object can be in more than one state simultaneously. In this case, the cat is inside a box with a flask of poison and a radioactive detector. Now, if the detector detects some radiation from the outside source, the flask is broken and the poor cat meets its demise. While the box remains closed, however, from the observer's point of view, the cat remains both alive and dead. It's only when the box is opened that you work out whether the cat is really alive or dead. And I think this demonstrates some of the strange effects of quantum mechanics. Quantum algorithms seek to exploit this to solve problems that can't be solved in traditional ways, because the data in traditional computers is dealing with binary data, that is ones and zeros, whereas quantum data effectively has an infinite number of values from 0 to 1, or alive to dead in this case. The focus of this research within the IT world is to demonstrate a quantum advantage, that is, computers that can be built to run and solve problems that existing classical computers just can't solve.
And we should say, shouldn't we, Neville, that no cats were harmed in the recording of this podcast. This is just a theoretical example, just to bring the concept to the fore.
Indeed.
I would say then, so if we look at the real essence of quantum, is it purely speed, Neville, that it brings, or is it some additional things beyond pace?
So quantum holds the hope of solving problems that existing computers just can't solve. For instance, one of the famous algorithms for quantum is Shor's algorithm, which deals with factorizing numbers. This is very important from a cryptography point of view. This algorithm, implemented on traditional computers, can take an infinite amount of time, but are quite solvable on quantum computers. Quantum technology itself opens the doors to solve a whole range of problems in the physical domain that we just can't currently solve.
So it's a combination of extra compute power, the ability to solve new things and to do it much quicker.
Yes, indeed.
So when one thinks about quantum and then thinks about when will it arrive, is that with us today, Neville, or where are we with the quantum journey?
Yes, quantum research has been ongoing for some time now, and in fact small-scale quantum systems are available through most of the cloud providers, and you can in fact buy small-scale quantum computers, i.e. those that have a very small number of bits. The time frame to reach the scale for solving general problems, though, is somewhat debated, but I think the consensus is that by 2030, the quantum industry will be a multi-billion-dollar industry, and many of the more general problems that we're looking to solve will be within within the grasp of quantum.
And when we see and think about quantum in that sense, in a very mature way, but then look at where we are today, what kind of impacts does quantum have on our lives today, or and will it have in the future?
Well, the internet is secured by encryption algorithms, and as the internet and the reliance on the internet has got more and more pronounced recently, all of these algorithms are very important to preserve the safety and anonymity of data. Quantum could radically change that overnight with the introduction of general quantum computers. Many of the current security algorithms may become vulnerable. This is particularly important for long-term data, such as biometrics that are stored. There's a number of people within the community for encryption and security that worry that people are stealing data today that can't currently be cracked, with the hope of cracking it in years to come when the algorithms become available. But quantum can also be used to solve a whole range of other problems that can't currently be solved. There's in a very broad range of areas, including things like health, mining, security, the financial industry, molecular modeling. The list goes on to some of the problems that could be solved.
And when you kind of take that very powerful outline that you've just described there, Neville, how do you think then quantum could be applied to the digital world more broadly?
Well, I think that quantum is more of an enabler technology, very much the same way that we think about GPUs are today. It's less likely that we'll see a quantum desktop computer on your desk in the near future, but highly likely that we'll see a quantum coprocessors. And even today, within the realm of supercomputing, there are a number of initiatives around the world where quantum computers and supercomputers are being combined to solve some of these very important problems.
So the real evolution in this technology is what I'm getting from this, and things are going to start to move pretty quickly. How can CGI help business prepare for quantum technology?
So I think there are many steps for businesses to become quantum aware and to become quantum ready. We can go through a series of steps of understanding where algorithms are used within current businesses, and then once we understand those, to look at those algorithms and to see where quantum and quantum advantages can be had over traditional and classical algorithms. And this allows us to find the true value of where quantum can be best applied. Once we've worked out the most strategic areas where quantum can be applied, we can then qualify the business value from some of these changes, bearing in mind that quantum implementation, especially in the early stages, is likely to be quite expensive. By coming up with the most strategic areas, we can then determine the advantage of using quantum to transform over the current systems.
I know that in our conversations, not only today, but in previous conversations, Neville, we've talked about this topic of quantum and impacts on security. And you mentioned it a little bit there earlier in the context of the internet. What do you think are some of the large-scale security items that need to be, we need to be aware of?
I think one of the biggest areas that quantum is likely to impact is in the area of security, and I think we can certainly help businesses to go through and determine the critical aspects of the business that are vulnerable to quantum attack, and then to identify the various cryptographic mechanisms that are being used to see where the most vulnerabilities are. We can go through and evaluate all these risks and the timescale to mitigate, to allow the businesses to translate through to a post-quantum architecture. And of course, it's always important to be able to test and plan the effectiveness of this. And I think we'll be going into the area of quantum security and how it can be used for both advantages and for businesses to become quantum ready in a subsequent podcast.
Neville, we'll look forward to that for sure. And just to kind of close us off today, I think we've covered quite a bit of ground, and thank you as ever for your time on this topic, Neville. If you were to take a step back, and if it is possible to ask the question, the future of quantum technology, what does it look like? I know it's just, arriving with us as you've been describing today, but where does that take us from a future perspective?
I think the development of quantum systems is touching on very fundamental areas of research in material science, mathematics, and computing. Through each of these areas, we are pushing boundaries, not just in computing, but in material sciences, health sciences, and genetics. So I think quantum will have quite a far-reaching impact on many of the things that touch our everyday lives. I think many of these new discoveries will have flow-on effects into areas that we even now can't imagine.
Well, Neville, we look forward to tracking the progress of quantum in our various markets when, of course, working with our clients as you've described. So thank you so much for your time today. And with that, I will close off our podcast. Thanks everyone for listening. As usual, you can subscribe via all the usual channels. And we very much look forward to connecting up with you all on the next Experience CGI podcast. Neville, thank you very much.
Thank you.